Okay, by taking calc 1, and this is for you to show you how to find the derivatives of all the trig functions. So here we go. Let's go and find the derivative of sin x first, of course. So right here, of course, we have to use the definition of derivative. So remember, that's equal to the limit as h approaching 0. And then right here, we will have f of x plus h. So in this case, we have sine of x plus h, and then minus the original function, which is sine of x. And then all divided by h, right? And now, be sure you write down the LIM as h approaching 0 again, because otherwise your teacher might take away some points. Not my fault, but just do it. Anyway, for this right here, we can break it apart with the angle sum identity for that, which is going to be sine of the first times cosine of the second plus cosine of the first times sine of the second, right? And then we still have the minus sine of x on the top, all divided by h. And now, here's the deal. You see that we have the sine x right here and also sine of x right here, right? So we can put them together and factor out the sine x. So next, we will have the limit as h approaching 0. And then I'm just going to write down the sine of x right here first. And you see this right here, we'll have cosine of h, and then this right here, we'll have minus 1. And let me close the fraction, so I'll put down over h right here. And then next, we have this guy, and then I will also put down the cosine x in red. You will see why. So I'm going to add cosine of x, and then times sine of h, and then all divided by h. And now, here is the deal. When we have the limit of the sum, this is actually the same as the sum of limits under the condition that both limits exist. They do exist, so we can do the following. Another thing is that, you see, this is h is approaching 0, so the sine x is just like a constant, so it doesn't matter. So you can put that in the front of the limit. So this right here becomes the following, and then we can just like distribute the limit pretty much. So I'm going to write down sine of x first, and I'm going to write down limit as h approaching 0, and we have this, which is cosine of h minus 1 over h, and then distribute the limit. As I said, I'm going to add cosine of x, and then times the limit as h approaching 0, sine of h over h. So that's what we have. Very nice. Now, here's the thing. We should technically do some legitimate proofs for this and for that, especially for this right here, should do some geometry proof for this. But you know what, usually when I teach Calc 1, I usually just teach like the students, hey, plug in the table of values and you'll see that h is maybe like 0.001, blah, blah, blah. And you will see that this right here is actually approaching 1, and this right here is approaching 0, so that's the limit for that. But if you guys want to see the legitimate proof for this, I will have the link in the description for your convenience, right? But just for this video, let me tell you guys the answer. But anyway, though, you'll see that this right here is just sine x times 0, which is bye-bye, and then right here we have cosine x times 1, which is just going to be cosine of x. So ladies and gentlemen, this right here is the derivative of that. And now, of course, we'll have to do the derivative of cosine x. And now you might be wondering, can we just do the same thing like that? Yes, you could, but I'll show you guys another way to do it. So right here, there's a very nice relationship between sine and cosine. In fact, I can put down sine right here first. And remember, cosine stands for complementary sine. What does that mean? If you have cosine x right here already, you can put on sine right here as long as you enter the complementary angle of this, which is going to be 90 degrees minus x, which is going to be pi over 2, because we're all those now. So please use radians. Now, the reason we can do that is because you see, right here we can differentiate sine because we know the answer from there already. So this right here becomes cosine, and then we have the input states the same. And now use the chain rule, so multiply by the derivative inside, which is going to give us negative 1. So have a look right here. This is going to be negative, and then cosine of this is going to be what? Yes, you guessed it, sine of the complementary angle of this, which is just x. Aha, we have negative sine x for the answer. Now, of course, you can see that I have to erase the board, and yes, I'm also showing off my t-shirt. But anyway, though, also that as well. But we have 4 more to go. I want to see if I can finish all this in 9 minutes or so, and I'm still trying to entertain you guys, so that's why I'm still talking. Alright, the next one we shall be doing what? Tangent, of course. So let's go ahead and do the derivative of tangent. Well, tangent is actually not so bad because we can write this as what? Sine x over cosine x, and especially now, we know the derivative of sine x already, sine and cosine x already, so we can use what? Yes, the quotient rule, right? So I'm going to use the quotient rule right here. I'll open a big fraction bar, and then I'm going to square the bottom, which is going to be cosine x, and then square that. And now remember, the quotient rule says, well, I'm going to put on the bottom function right here, cosine x, and then multiply by the derivative of the top, which is going to give us cosine x, and remember it's minus, and then the top function, which is sine x, and then multiply by the derivative in the bottom function, which is going to be negative sine x. Aha, very nice, right? And now you see, this right here is going to give us cosine square x, and then minus becomes plus, and then we have sine square x. Very nice. And over this right here is going to be cosine square x. Very nice. And you see this right here, cosine square x plus sine square x is equal to what? Yes, it's a famous number 1. So this right here is just nicely equal to 1. 1 over cosine square x is equal to what? Yes, that's going to be secant square x. And then we are done. Derivative of tangent. Now let's do the reciprocal version of tangent x, which is going to be cotangent x. You can use the same thing that we did earlier, but I want to practice the quotient rule with you guys one more time. So this right here is equal to what? Yes, the derivative of cosine x over sine x. And again, let's use the quotient rule. Right here, I'm going to square the bottom, which is going to be sine x and then square. And then I'm going to put out the bottom function, it's going to be sine x right here, and multiply by the derivative of that, which is going to be negative sine x. And again, minus the top function, which is going to be cosine x, and then multiply by the derivative of bottom, which is going to be another cosine x right here. Now have a look. This time this is going to give us negative sine square x, and this is going to give us negative cosine x. But this right here has a square, and over this right here is going to be sine square x. And now you see plus all this together is going to give us 1. We have minus minus, we can factor out negative 1, and it's going to be what? This right here is going to give us negative 1. So this is going to be negative 1 over sine square x. So this is going to be negative, and of course cosecant square x. That is it. Now we have 2 more to go. And for the next 2 I'm not going to do the quotient rule. I'll show you guys another way to do it. So you can see that when you're doing the derivative trig functions are really fun. And also I'll show you guys how to do the derivative of the inverse trig functions in the next video, not for this one, right? So I'm going to see. Alright, erasing the board. Let's see. Next one, let's do cosecant. So let's go ahead and put down d dx, and let's see cscx. Oops, cxc, and then we have the x right here. And now what's cosecant? Of course, it's 1 over sine, right? So I'm going to write down this is the same as taking the derivative of 1 over sine x. Well, what's 1 over sine x? We can write this down as well. Taking the derivative of sine x and then raised to the negative 1 power. But remember, this right here is not the inverse sine function. This right here is just really means 1 over sine x when you write the parentheses with a negative 1 power right there, right? And the purpose I want to do this is because we can use the power rule, bring the power to the front and minus 1. So you can see that we will have negative, and then the inside stays the same right here. And then negative 1 minus 1, of course, is negative 2. And then don't forget the chain rule again. Multiply by the derivative inside the derivative sign is going to be cosine. So as you can see now, this is what we have. So right here, I'm just going to write down negative cosine x on the top over, we have sine x squared, right? This is very nice. Now check this out. I'm going to write this down as well. We have negative 1, and this is cosine x, and then over sine x squared is the same as saying sine x times sine x. So the first sine x is going to be in red, and the next one in black. So all in together, you can see that we have negative 1 over sine x is equal to cosecant square. No, cosecant x. There's no square, of course, I just lied. This right here is going to be cotangent x. Yes, as you can see, this right here is the derivative for this guy. And of course, the next one is going to be secant. So taking the derivative of secant x. I cannot even see my hand, I don't know why. But anyway, this right here is the same as saying taking the derivative of 1 over cosine x, and yes, we'll pretty much do the same thing, right? So this right here is going to be taking the derivative of cosine x, and then you put down to a negative 1 power like this, and then you can see that, well, I can use the power rule, bring the power to the front and minus 1, and then you can see this right here becomes negative, parentheses inside stays the same, cosine x, right? This is a c, and then raised to the negative 2 power, and then multiply by the derivative inside, which is going to give us negative sine x. In this case, negative times negative is positive, so we just have positive sign on the top, and then over this guy on the bottom, which is cosine x and square. Again, we'll do the similar thing. So this right here becomes 1 times sine x, and then over the first cosine will be in red, and the next cosine will be in black. And as you can see, 1 over cosine is equal to secant, so let's put down secx, and then for the next one, we will have tangent x. Aha, we are done.